In this video, I will show you how to use z-scores to find the percentage of data between two values. Alright, you're going to need a z-score table to do this, so if you don't have one, get one. Maybe Google this phrase and print one out. Let's learn from this example. In 1999, the scores of men on the math part of the SAT followed a normal distribution with a mean of 531 and a standard deviation of 115. What percentage of men scored between 425 and 555? Now, when they say a normal distribution, they mean a bell curve like this. So here's how I recommend organizing our work. So I'm just going to divide our workspace into 4 sections. In the top 2 sections, I'm going to do graphs like these. All right, now of course I'm cheating with the cutting and pasting. You'll have to draw them yourself, but that's okay, it's pretty simple. Now on the left graph, I'm going to deal with the context of the problem. What's the problem about SAT scores? So those are the numbers that I will have on this graph will be in the form of SAT scores. Now we're going to turn those SAT scores into z-scores. And that's what's going to go on this graph. So let's start with the SAT scores. They mentioned that the mean is 531. So that goes right here on the graph, right? This line right down the middle represents the mean. Standard deviation comes later. What percentage of men scored between 425 and 555? These are still SAT scores. I better make my writing smaller so I can fit it. So let's see, 425 is below the mean, so I'm going to put it over here somewhere, 425. 555 is above the mean, so I'm going to put it somewhere over here. Okay, and we want to know what percentage of the data is between these two numbers. So we want to know what percentage of the men fell inside of this yellow area. Now, in order to use our z-score table, we're going to need to translate these SAT scores into z-scores. So I'm going to have these z-scores represented like this. All right, the z-scores that correspond to these SAT scores. And now, first of all, on a z-score graph, the mean is always 0. All right, so any z-score, any negative z-score means that it is below the mean. A positive z-score is above the mean. So how do we translate regular values into z-scores? So you have the following formula. To find a z-score, you take whatever value you have, you subtract the mean, and you divide by the standard deviation. So I'm about to do that twice. Okay, first with the 425. So when I find this first z-score, I'll call it z1. I'm going to do 425, right? That's my value, minus the mean, which is 531, divided by the standard deviation, which is 115. Okay, just put that in your calculator real quick. All right, the calculator is giving me this. Now I want to round this down to 2 decimal places, the nearest hundredth. Now I want to be real careful as I round this down before I erase this last number. If this number were 5 or higher, I'd have to round this up to 0.93. But since it's a 1, I can just erase it. Okay, so that's my first z-score. all right, which corresponds to the 425. So I'm going to put that right here, negative 0.92. All right, that's almost negative 1. That means it's almost 1 standard deviation below the mean. All right, notice that negative means that it is below the mean. Now let's do that again with the other z-score. All right, I will call it z2. So that's going to be 555 minus 531, again divided by 115. Okay, put that in your calculator. All right, calculator's giving me these numbers right here. Now remember, I want to cut this at 2 decimal places, but I have to be careful. I need to look at the number, the next number after this. If this is 5 or higher, I need to round this number up. So since this is an 8, this has to be rounded up to 21. All right, now that's very important. If you round wrong, your answer is going to be just completely wrong. All right, so it's more important than ever to round properly. Okay, let's get back down to business. So we want the probability, or the percentage of men who scored between these two z-scores. Oh, I forgot to record the other z-score. So over here we have 0.21. So look, the relationship between these two graphs is, even though here I have SAT scores, here I have z-scores, the percentages should be the same. Okay, so the percentages that fall between these two z-scores should be the same for SAT scores and z-scores. All right, here's where that z-score chart comes in. So the z-score chart tells us the percentage of data to the left of any particular z-score. So it's those left percentages that we're going to use right now. So look, we've got this z-score of negative 0.092. So we're going to find the percentage of z-scores to the left of that number. Okay, we're just going to read that right off the chart. Oh yeah, what's that number? Negative 0.92. So let's see. So here we have negatives. I'm looking for negative 0.9. Okay, so there's negative 0.9. Now we want negative 0.92. Okay, now look at this, the tops of these columns. This is 0.0, and this is 0.01, 0.02, 0.3, 0.4, etc. So this number would represent negative 0.90, negative 0.91, and negative 0.92. So this is the value that I want. Okay, I missed. Oh no, now I got too many. Let me try this one more time. Okay, I'm just messing up. Okay, there we go. Now, as a percent, this is 17.88%. So let's write that down. All right, 17.88%. Okay, now let's find the value. All right, the percentage of z-scores to the left of the other z-score, 0.21. Okay, so let's find 0.21. That's a positive number, so it's going to be on this page. Here's 0.2. Now this would be 0.20. This would be 0.21 right here. That's 58.32%. All right, 58.32%. All right, so this is the percent of data to the left of this z-score. This is the percent of data to the left of this z-score. Now, what we want is the percentage of data between these two z-scores. So here's how I'd write that down. Okay, if I want to be between these two z-scores, then that means negative 0.92 is less than the z-score, which is less than 0.21. This is how you write between, and this means the percentage of data between. Now, to calculate that, all you do is subtract. Just do the bigger one minus the smaller one. So I'm going to do 58.32% minus 17.88%. You just subtract. Okay, I'm just going to put that in my calculator real quick. And I'm getting 40.44%. All right, so that's the percentage of data between these two z-scores. All right, so that means this right here is 40.44%. Now remember, the percentages should be the same for the z-scores and the SAT scores. So that means the percentage of data between these two SAT scores will also be 40.44%. So that is the answer to the question. So that's really what this fourth quadrant is for. I'm going to go ahead and write this up. Anytime you have a real-world problem, you shouldn't just answer it with a single number. You should answer it with a complete sentence. So here's the bottom line. 40.44% of the men who took the SAT in 1999 scored between 425 and 555 on the math part.